Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. I am welcoming you all to this beautiful online learning platform once again. And we are happy to announce that now Unacademy is going to providing online training for GATE and engineering service exams with India's top educators. So India's top educators and experienced faculty are going to handling the classes. About myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI domain. Now, see here how we check how to get Unacademy learning app into our device. Just go to Play Store, type Unacademy, then it will shows the Unacademy learning app like this. By clicking this install button, it will install the Unacademy learning app into your device. So here are the few of the top educators from Unacademy. Tiwari sir, he is IIT topper. Ankit Goyal sir, he obtained All India first rank twice in GATE Electrical, and he was awarded President of India Gold Medal in IIT Indore. Sanchit Jain sir, he is a computer science faculty. He has more than 8 years of experience. JASPAL Singh sir, he is ex-IAS officer. He got All India 4th rank. Here are few more top educators from Unacademy. See, recently we conducted one scholarship test, and frequently you get the scholarship test from Unacademy for all departments. Now, in March 14th, 2021, these are the toppers from electrical department and electronics and communication engineering departments. Now, they won 100% GATE plus scholarship. They don't want to provide pay any single NP. They are providing 100% plus scholarship. Now we are challenging and original GATE questions what you are expecting in the upcoming GATE examination. We are providing those questions to the students in the examinations time. So they are prepared by India's best educators. Best Unacademy educators are going to preparing those things. And live leaderboard we are providing. Live leaderboard in the sense, once you've written one question attempted, now all India level what is your rank? Based on your speed and accuracy, we are providing that all India rank to you. Now take it in live and to compete with the best. So after GATE examination, rank is provided to you, that is all India rank. Okay, so everything you need to compare with all India level, not at your college level, not at your institute level, okay, where you are studying, and not with your friends, your friends. You need to compare with all India level. So because of that, to compete with the best who is the best while writing the examination, and compare to him where we are. So you can get this knowledge and this idea from this. And so identify and improve your weak areas with a detailed video solution. See, after completion of examination, we are providing a detailed video solution to you. From that, during the exam, whatever the questions you are unable to answer, you can get the clear picture information about that concept and how to solve that problem. You can get that one. Now, score. Get scores for you as the speed and accuracy. We are providing a score and leaderboard. So to know your rank after every combat, after attempting every question, you can get your rank where you are. And so in the month of March, we conducted 1.8 crores of scholarship. We provided to the students, and this is the competition format. 20 questions, 60 minutes of time, 5 different departments: mechanical, civil, electrical, ECE, computer science and information technology. And the relative scoring also we are providing based on speed and accuracy. Here are the highlights. weekly scholarship test we are providing, and within 60 minutes you can assess where your GATE preparation is. And original questions we are providing in the examination, original questions, original GATE questions. Okay, and take it alive. All India live leaderboard we are providing, and after the exam detailed video solutions we are providing. And don't forget to use my code VRAW10 to unlock the exam. Don't forget to use my code during registration. Yeah, now ESE Engineering Service Exam 2021 test series is going on. ESE 2021 test series is going on in Unacademy. So these questions are curated by the India's best educators, and all India live ranking is provided if test is taken live, and it was designed as per changing demand for ESE. In that 10 questions we are providing, 20 minutes of time giving. So these are the departments: mechanical, electrical, civil, electronics and communication. For these departments we are conducting, and general studies also separately conducting for common to all. And don't forget to use my code VRAW10 to unlock the test. And full length mock test also we are providing. So in that 150 marks, 150 questions and 180 minutes of time. These are the departments for that: mechanical, electrical, civil, electronics and communication engineering. And yeah, there is a golden opportunity for civil engineering students who are willing to move towards engineering service. So crack engineering service with the JASPAL SINGH sir. Join us for free test series. So topic wise test series we are conducting. Topic wise test, these are the topics and the dates on which your test is going to be running. Okay, it is JASPAL SINGH sir. You know that his credentials: he was the ex-IAS officer, he got All India 4th rank. Now Ultimate 10 SSC series is going on. Ultimate 10 SSC series is going on for mechanical engineering students. In that 10 questions, 20 minutes of time. Timing is at 10 AM. These are the dates on which exam is conducting. Okay, even though dates are completed, now you can take the test even after live session also. That facility is there. In future also you get more number of this type of opportunities you get in more future. Same way, same SSC 10 series for electrical, 10 questions, 20 minutes. Same SSC 10 series, civil engineering, 10 questions, 20 minutes of time. And kickstart your GATE 2022 preparation by following our series of exams. In that 10 questions, 20 minutes of time, we are every week, Tuesday, Thursday and Saturday, we are conducting this session at 10 AM. See this weekly, 3 times we are conducting exam. In every exam we are providing 10 questions. That type of weeks you get a worst case you get 4 weeks in a month, worst case, or minimum. Now it is 120 questions. Monthly you are getting minimum 120 questions. 120 is, in that you can expect a minimum of worst case 80 plus different model questions. Now if you follow this minimum 10 months, now 800 plus different models you can get, and solution videos for those questions also you get. So once you get all those things, no need to do anything, just by following those questions effectively also you can crack your GATE examination. So it was curated by best educators. These questions, All India live ranking is provided if test is taken live, and designed as per the challenging demand for GATE. And don't forget to use my code unlock VENKATA10 to unlock it. Okay, now we are happy to announce that recently we started 2 new batches, one for GATE 2023, other one is for GATE 2022. Okay, the faculty who are handling the subjects for GATE 2023, are handling these batches for 2022 also. There is a Ascend batch for GATE 2022. It was GATE 2023 for mechanical engineering. It was started from 22nd February 2021. And here are the top faculty who are handling the subjects in that. And next there is a Evolve batch for GATE 2022 for mechanical engineering itself. The same faculty are handling the subjects. It was started from 22nd February. And mission DDR is going on for mechanical engineering students for GATE 2022. This is for mechanical students. It was started from 22nd February 2021. Now there is a Spark batch going on for GATE 2022 for civil engineering students. This is only English batch. And these are the faculty who are handling the subjects in that. This is the date on which exam is going. This batch is started 22nd of February 2021. Okay. Now there is a Ascend batch going on for GATE 2023. So these are the team of faculty members. Here JASPAL SINGH sir is there. And it was started from 8th February 2021. And this is for civil engineering department. There is a Evolve batch for GATE 2022 for civil engineering. So the same faculty who are handling the 2023 GATE, the same faculty are handling these subjects also here. And next there is a Evolve batch for GATE 2022. This time this is for computer science and information technology. Okay, and this batch was started from 8th February 2021. And Ravindra Bambu sir is there. He is the one of the top faculty in this, and he is the first ex-alumni of IISc Bangalore, and he was the first faculty who started the online training for GATE examination. And there is a Ascend batch for GATE 2023 electrical engineering. Here are the team of faculty who are handling the subjects in that, and it was started from 1st February 2021. Next there is a Evolve batch for GATE 2022, same electrical department. It was started from 1st February 2021. There is a Ascend batch for GATE 2023 electronics and communication engineering, and this batch was started from 1st February 2021. And again there is a Evolve batch for GATE 2022 electrical electro ECE, and it was started from 1st February 2021. Again Evolve batch for 2022 GATE chemical engineering this time. So it was started from 25th January 2021. Just we glance what are the different engineering disciplines available in an academy for GATE and engineering service exam. ECE, chemical engineering, mechanical engineering, computer science and IT department, instrumentation engineering, electrical engineering, civil engineering, and last but not least production and industrial engineering. These are the different engineering disciplines available. Now there are two plans. First one is a plus plan, second one is iconic plan. Plus plan, it is the basic plan. Iconic plan, take your preparation to the next level by providing a personal coach. Here in plus plan, India's best educators are handling your subjects. Interactive live sessions are there, structured courses and PDFs, live tests and quizzes are there, and the things what you are getting here also getting same thing here also you are getting. Okay, and here we are going to show the difference. Live tests and quizzes. Once you attempt an exam, test or quiz, it was properly analyzed by your personal coach, whoever provided to you, and they prepare a they do the personalized test analysis, where you are strong, where you are weak, where you are doing mistakes, where you need much preparation, where you need to do much analysis, which topics, all such type of things they will analyze, and they will prepare a proper study planner to you, and they provide respective study material to you. So by following these two, every student can get success in their examinations. By following these two, every student can get success in their examinations. Now see, these are the different plans available: 1 month subscription, 3 months, 6 months, 1 year, 1.5 and 2 year subscription. And here the beauty is EMI option also available, and for a 1 year its cost is 30,250 rupees. By using my code VRAO10 during subscription, you get it by 27,225 rupees. You get it by 27,225 rupees. Okay. And if you joined outside to take offline training, so throughout year during public holidays and weekends, generally offline classes are going on. So only for those days to travel from your home to the institution where you are taking training and back to your home, for transport charges only 20,000 plus rupees. By adding little bit amount to this, you can complete this GATE training by staying at your home itself. No need to move anywhere. And one more important thing is, India's best educators are going to handling your subjects. Don't forget that. And next, iconic plan. Iconic plan is available in 1 year and 2 year subscription. For 1 year it is 50,250 rupees. By using my code, you get it by 45,225 rupees. 45,225 rupees. Okay, and don't forget to use my code VRAO10 during subscription. Okay, now and this amount is more or less the amount equal to the what you are paying offline tuition fee for offline training at outside. And one more, some of the institutions are charging 1.5 times or 1.6 times of that amount. And don't forget, with that amount here you are getting personal coach also. After writing the exam, your test is analyzed by the personal coach, and they will provide proper study planner to you and respect to study material also to you. So more benefits you are getting here compared to others. So my dear students, please think once of it and discuss with your parents, discuss with your friends, and discuss with your faculty members, those who are having knowledge on GATE and engineering service examinations, and take a right decision. Transistor biasing. Okay, already we completed some part in that. Now see, just 2 minutes I remind that. See, active region of operation is nothing but a transistor biasing. Here our intention is to operate the transistor in active region. See, in this what we done, emitter junction is forward bias, collector junction is reverse bias. That is the meaning of active region. But here we are using two power supplies. That is the problem. So now our intention is to operate the transistor in active region with a single power supply. So these are the sequence of steps you need to follow for proper biasing of the transistor. First, operate the transistor in active region. After that, fix the operating point in active region. Next, stabilize the operating point. Now first I am going to operating transistor in active region. So we know what is active region. This is cutoff. This is the VCE versus IC is nothing but a CE output characteristics. In that, VCE output voltage, IC output current. Now the plot between these two is by keeping base current constant. This is the minimum base current, and this is the IB0, and this is IB1, like that. So why I am calling this is IB minimum is, if you maintain this much minimum base current, you can switch your transistor from active to saturation because of that. Okay, that is the reason why. And this is the active region. So we need to take an operating point in this region. See this? This is active region. Now we need to operate our transistor in this region. Operating transistor in the region in this sense, at output it will provide some VCE voltage and some collector current it will maintain. Now I want to compare these two. Now I want a value of what is VC, what is IC. For example, some value of VC I got here and some value of IC I got here. Now this is the point that VC comma IC what you are getting is called operating point. So our intention is to keep that operating point in active region. So these are the different possibilities. Anywhere you can take operating point, but infinite possibilities here. But we need to keep only one point. So to solve that problem, I am taking the help of a DC load line. See, there are infinite possibilities to solve that problem, but we need only one point, operating point. I am taking the DC load line. So DC load line is a line joining the DC load line is a line joining the saturating point and cutoff point. This is the saturating point. A point in saturation region is in a saturating point, and a point in cutoff region is a cutoff point. Now the line joining these cutoff and saturating points is called DC load line. Now your operating point is in active region and on DC load line. So in between from this point to this point, it should be anywhere. Now, so again you can take any point on this. So infinite possibilities. Here you can take, here, anywhere you can take. Again it comes to same problem, infinite possibilities. To solve that, I am taking the help of characteristic curve. That means at different base currents we are plotting this. Plot the VC versus IC. I am taking at that one at different base currents. See this, IB1, IB2, IB3. At a different base currents I plot it. This is at IB1. This is the plot. IB2 plot. IB3 plot. Okay, these are the different plots. Now this is IB minimum base current required to switch the transistor from active region to saturation region. Okay, now our operating point is in active region on DC load line, and it is also on characteristic curve. That means now it became intersecting point of characteristic curve and DC load line, either this one or this one. Now this may be also, this one and this one also has to be considered, but not giving priority. Why? Because this is the region. After this region immediately we have a saturation. This is the border of active region towards the saturation side, and the same way this is the border of the cutoff region, active region towards cutoff side. Okay, cutoff region side. That's why I'm not giving priority to these two. So I'm considering only these 3 points. See this. This is the line. So this is the DC load line. Now Q1. So here is the point Q1, Q2, Q3. Now operating point is any one of these. So now our problem is, initially we have infinite possibilities. Now infinite possibilities to only 3 possibilities, either Q1, Q2 or Q3. Now if I take Q1 is the operating point, then what happens? See this. If your operating point is Q1, then so positive side there is a limitation on increasing the signal because it is limited by IB minimum. Okay, IB minimum, that means the value of IB minimum is nothing but at that point we get IC maximum. So IC maximum is limiting the positive movement or positive excursion of the signal. Okay, and the negative side you can move up to here, no problem. So If I try to increase the input signal more than this, then that portion which is above the IC maximum is going to be clipping. So now if I am taking Q1 is the operating point, the positive excursion of the output signal is limited due to IC maximum. Same way, if I take Q3 is the operating point, okay, the negative excursion of the output signal is limited due to IC minimum. Same way, IC minimum. So because of that, I am going to taking the Q2 is the operating point. It is the midpoint of the DC load line. By taking this one as the operating point, you can take your signal like this. So symmetrical it is. Whatever the positive excursion, similar amount of negative excursion, more or less. So symmetrical signal you are getting at output. So operating point is the midpoint of the DC load line approximately. Okay, so far we know what is operating point. So once you know operating point, you need to keep that operating point stable. Stabilize the operating point. You may ask one thing, sir, I am not going to disturbing that. I am not going to disturbing that anymore. So why don't it stable? See, it is not stable because IC is varying with respect to IC naught. IC naught is not a constant. It is a function of temperature. Okay, once you are operating your transistor continuously, temperature change takes place at collector junction. Once that temperature change takes place at collector junction, automatically IC naught changes. Because for every 1 degree centigrade rise in temperature, IC naught increased by 7% for every 1 degree centigrade rise in temperature. Okay, so that is the reason. Okay, so you need to keep IC constant. If IC is constant, automatically VC also constant, because VC purely depends on IC. So this is your IC equation. IC is beta times IB plus 1 plus beta times IC naught. Now IC is a function of IC naught comma IB comma beta. IC naught is varying with respect to VB. If VB is changing, IB changes. Now one current, voltage and beta. So now the change in IC with respect to these three parameters, I am representing that by using a Taylor series like this. Now this change in IC with respect to IC naught represented by a stability factor S, and change in IC with respect to VBE is represented by a stability factor S dash. Change in IC with respect to beta represented by a stability factor IS double dash. These three are called stability factors. Now stability of operating point is represented in terms of these stability factors. For a better stable point, for a better circuit, stability factor is 0 ideally, because change in IC you are representing. But ideally we need to keep IC constant. So IC constant means delta IC is 0. Okay. And in that we are giving high priority to stability factor S, because IC naught damages more part of IC compared to remaining. And yeah, so this is the S dou IC by dou IC naught by keeping VB and beta constant. Now I am going to deriving an expression for this. This is the beta IC value and differentiating this with respect to IC itself. Now after differentiating this one, here dou IC naught by dou IC, we can take it 1 by S. So S is, by simplifying all these, I got S is 1 plus beta by 1 plus beta into dou IB by dou IC. So just by taking differentiating IB with respect to IC, you get the stability factor. Take that value, substitute here, then you get stability factor. And practically its value is in between 1 to S plus 1 plus beta. Ideal value of S is 0, already we observed, but practically for a good circuit, S value is 1 to 10. If stability factor is 1 to 10, now you can call it as a good circuit. Okay. Now, to calculate the operating point of a given circuit, and we need to follow the following steps. First calculate the IB by applying KVL to input loop. In that process, in your equation, if IC is there, just write that beta times IB, and IE is there, write that 1 plus beta times IB, and calculation of IC and IA, second step. So the same equations I am using. IC is beta times IB and IE is 1 plus beta times IB. Calculation of VCE. So by applying KVL to output loop, you can get the VCE value. After that, operating point is VCE comma IC. This is your operating point, VCE comma IC. So different biasing circuits we have: fixed bias, collector to base bias, and self bias. Now, so this is the fixed bias. We calculated the operating point of this by applying KVL to input loop and KVL to output loop by following the previous steps. So this is about introduction and fixed bias. Okay, after that we completed self bias also. Sorry, fixed bias, collector to base bias also we completed, and we calculated stability factor also. Okay, this is collector to base bias. Next, yeah, this is collector to base bias. Now I am going to self bias. This circuit is very important. Now first I am going to drawing the circuit. So this is the circuit diagram of it. Is plus VCC is called R1, R2, RC, RE. This is the circuit diagram. Okay. Now, in future reference, we need this circuit. See this? This is the circuit diagram of self bias. Now, for my easy understanding purpose, I am changing the circuit into like this. For easy purpose. Plus VCC, the meaning of this is R1 is having plus VCC, RC also having plus VCC. That's it. And this portion, whatever the portion here it has, this portion I am taking as usual. As usual, I am taking that portion. Okay, and the remaining portion of this is going to be replaced by its Thevenin's equivalent. Okay, now I'm copying this circuit. See this? This is our circuit. Now I'm taking this circuit like this. Second half I'm taking as usual. Second half I am taking as usual. Second half I am taking as usual. Second part it is. Now first half R1 R2 plus VCC. I am replacing that one by its equivalent Thevenin circuit. Now that is RTH and VTH. VTH. RTH and VTH. Okay, and now here RTH value is okay. Now I'm copying this circuit once again for reference purpose. See this? Here the value of RTH is simple. Just by applying Thevenin's theorem, it is equals to R1 parallel with R2, and VTH is nothing but a voltage across R2. Just applying voltage division rule. VTH is VCC into R2 by R1 plus R2. R2 by R1 plus R2. VTH is VCC into R2 by R1 plus R2. That is the VTH. And now here I am doing little bit modification. See, the resistor which is connected to the collector terminal we are calling RC, and a resistor which is connected to emitter terminal calling RE. The same fashion, the resistor which is connected to base terminal I am calling it as RB, and the supply at collector we call plus VCC, and emitter connected to ground, it's okay. Now the same way the supply what we have in base terminal I am calling it as VBB. Okay, now I am going to take this circuit with these new values. Yeah, now this is the circuit. I am completing the input part. Here we have RB and VBB. So it is VBB, it is RB. Our intention is to calculate operating point and stability factor of this circuit. Now the between base to emitter we have VB as usual, and this is the current IC, sorry, IB, base current, and this is the current IC in collector terminal, and this is the current IE in emitter terminal. We know that. Now in step 1 I am going to applying KVL to input loop. Starting from here and moving this side like this. This is the KVL to input loop. Now from this, supply VBB equal to, in this loop after supply we have RB. Now drop across RB is IBRB. After that we have base terminal. Now between base to emitter we have VBE voltage, and from emitter to ground we have IERE. That's right on just. Therefore VBE is, here I am applying KVL to input loop. So in that process, VBB is IB into RB plus VBE plus IERE, and in this, so we know that IE value is nothing but IB plus IC. Now I am substituting IC is beta times IB, we know that, and it is 1 plus beta times IB. Take this one, substitute here, therefore VCC minus, taking this VBE this side, VBE equals to IB into RB plus IE is nothing but a 1 plus beta times IB into RE. Now take IB common here and take this remaining part this side. Therefore, we can write IEB is VCC minus VBE by, sorry sir, it is VBB not VCC, sorry. So it is VBB minus VBE by RB plus 1 plus, so 1 plus beta times R, that's it. So that is the IB value. Now similarly I am calculating IC. We know IC is beta times IB and IE is 1 plus beta times IB. So far we know all terminal currents. Now I want to apply KVL to output loop. So I am going to apply KVL to output loop. So copying the circuit. Now applying KVL to output loop. So here is our VCA, voltage between collector to emitter. VCA. And now I am taking the output loop. So starting from power supply, VCA and to ground to VCA. Now therefore it is VCC is equal to next RC. So drop across RC is ICRC plus VCA plus IERA. Therefore operating point value VCE is voltage, VCC minus, because we know previously just before we calculated IC and RE, IC and IE, ICRC into IE, that is the value. Therefore operating point is VCE comma IC, VCE comma IC. Okay, so after that operating point we need to calculate stability factor. Okay, now we know the equation for stability factor. Stability factor is S is 1 plus beta by 1 minus beta into DIB by DIC. This is the equation for stability factor, but in competitive exams it is difficult to us to apply so you need to reduce as many, you have to use as many less number of steps, okay, in competitive exam. Now I'm using that one. There is an equation, simplified equation, we mentioned that is stability factor of any circuit is 1 plus beta by 1 plus beta into sum of emitter current carrying resistors by sum of emitter current carrying resistors plus sum of base current carrying resistors. Simple. Now I am applying the same thing on this. Therefore S is 1 plus beta by 1 plus beta into emitter current carrying resistor. In RE we have only IE current. So RE by RE plus emitter current carrying resistor plus base current carrying. So here IC current, here IB current. So RB. That's it. This is the stability factor. Now we do little bit work on this. Okay, now I am taking the stability factor. So our stability factor is S is 1 plus beta by 1 plus beta times RE by RB plus RB. Okay, now I am taking RE common in denominator in this RE ratio of resistors. Taking RE common. Now it is 1 plus RB by RE. So it is 1 plus beta by 1 plus beta into 1 by 1 plus RB by RB. You observed one thing or not? Your RB is nothing but a parallel combination of R1 and R2, and practically R1 R2 values are much difference. R2 is sorry R1 is 10 times R2. R2 is less. Practically R1 is taking 10 times R2. Why? Because if I take R1 R2 are equal, then 12 volts is equally distributed across R1 and R2. See, this is the setup at input side. We are connecting this one to base. It is plus VCC. R1 R2 we are taking like this. Okay, if I take both are equal, R1 R2 are both are equal, then the supply volt we have VCC is equally distributed by R1 and R2, equally sharing. Now drop across R2 is going to use to take your transistor into respective region. Here if I take R1 R2 are equal, then more voltage, that means 50% of VCC is a drop across R2. So due to that high voltage, your transistor is entered into saturation region. Because of that, R2 is small compared to R1. Okay, sorry, compared to R1, R2 is small value R2. Is it okay? Now, generally we are following this one. R1 is 10 times R2. So there is a 10 times difference. If I take it is 2.3K, now it is 23K, 3.3K, 33K, 1K, 10K, that much variation. So that too we are taking parallel combination RB. So because of this parallel combination, RB value is much less than the RE practically. So once it is much less than that, it means RB by RE value is much less than compared to 1. Once it is much less compared to 1, whatever this expression 1 plus RB by RE, we can take it approximately 1. So you can neglect that. So after that, I am writing our stability factor is 1 plus beta by 1 plus beta into 1 by 1 plus RB by RE. So when RB by RE is much less than 1, then I am taking 1 plus RB by RE is approximately 1. Therefore, stability factor is 1 plus beta by 1 plus beta into 1 by 1. 1 by 1. So it is approximately 1 plus beta by 1 plus beta. It is 1. So stability factor is 1 in this sense. So stability factor is low. So stability of the circuit is high. Therefore, stability factor is low. Is low. So what it means? Stability of the circuit is high. That means stability of operating point is high. Stability is high. Because of this only, because of this high stability factor, we are going to using this self bias circuit in the designing of amplifiers. Okay, in the designing of amplifiers we are going to using this self bias circuit because of these reasons. Is it okay? Now, so I'm going to doing little bit another equation I'm going to derive for stability factor. So you mentioned it is 1 plus beta by 1 plus beta into R E by RB plus RE. Just to simplify this, RB plus RE into 1 plus beta by RB plus RE plus beta times RE. So now it is RB plus RE times 1 plus beta by RB plus 1 plus beta times RE. See one thing here, just before you mentioned RB is equal to R1 parallel with R2, parallel combination of R1 R2. That is the equation for RB, and it is low value because it is parallel one, and RE is, and that 1 plus beta times of RE is much greater than 1, much greater than, that means much greater than RB. This one is much greater than this, so you can neglect that. So once it is happened, therefore you can take RB plus RE times 1 plus beta is approximately RE times 1 plus beta. So that is the value. Now substitute that one here, therefore it is RB plus RE into 1 plus beta by, it is 1 plus beta times RE. Now this 1 plus beta gets cancelled, beta. Now the remaining part is RB plus RE by RE. So that is 1 plus RB by RE. This is the another equation for stability factor, and we know that RB by RE is much less than 1. So it is 1 plus very small fractional part, 1 plus small fractional part. Okay, so sometimes they will provide resistor values or resistor values of the circuit, and they will ask the what is the equation for that stability factor. Okay, so you should be ready with answering all questions. Sorry. And so this is the circuit. So far we completed self bias circuit. There is a reason for each and every resistor we are using here. So as a electronic student, you should know the meaning of reason for each and every resistor what we are placing. R1, R2, RC and RE. See, the first set of values are R1, R2. R1, R2 are called biasing resistors. Biasing resistors. Okay. Their function is to provide sufficient base current to take the transistor into active region. That's it. Up to active region it will take. Okay, now once you entered into active region, now your collector current also going to be maintaining in active region. Now the purpose of RC is, this is called collector resistance. And its purpose is to control the collector current and to control the IC and to operate the transistor in active region. To operate and to operate the transistor in active region. First, base current is taking transistor into active region. After that RC is going to maintain the IC in active region or transistor in active region. And this is called emitter resistance. And its function is to provide stability or thermal stability. And we are calling it as self bias because of, if any current increment, for example base current is increasing, now transistor, there is a chance of transistor entering into saturation region. So once base current is increasing, here emitter current also increases. Once emitter current is increasing, drop across IE increasing. Once the voltage at this point is increasing, this junction is going to be operating in a less forward bias. Less forward bias means base current is decreasing. So again your transistor is written back to active region. Okay, so by its own it is going to modifying the things. Because of that we called it as self bias. Okay, thank you. These are the topics. This is about your self bias. And thank you, thanks to one and all spending your valuable time with us. And don't forget to use my code VROUT10 during subscription. Please hit the bell icon and don't forget to subscribe us. Please give your valuable comments on YouTube and please join our Telegram group for getting latest updates on our upcoming videos. Now thank you very much. Thanks for spending your valuable time with us. Thank you.